So we are moving on with 7.2. Right, 7.2, refraction at a spherical surface. Okay, you have learned this in school. Okay, let's say we have a glass of water and then you put a straw, and then when it go through the water, the straw will refract it a little bit. It will change direction a little bit. So refraction is the changing of the direction of a light ray and its speed as the light ray passes from one medium to another. Or it means that when you change medium, the light will refract it. Next is the Snell's law. This one you have learned in the school before. Let's say we have two mediums and then this is the normal. Okay, so this ray is incident ray and then this is refracted ray. So this is incident angle, refracted angle. So the top one is the air medium and then the bottom one is the water medium. So ray comes from air to water. And the Snell's law states that n1 sine theta 1 is equal to n2 sine theta 2. Okay, next for refraction at a spherical surface, we have two cases as well. So the first one is a convex surface. And another one is concave surface. So convex surface, it looks like this. And then the concave surface, it looks like this. Yeah, and same with before, we have an imaginary circle there, and this is the center, and draw the axis. Okay, so we have the object here. Let's say this is the object, and the ray will refract it from the object, and it will produce image somewhere behind the surface. We don't know where. So from the vertex to the center, we call as r, radius of curvature, and from the object to the vertex is u, which is the object distance, and from the image to the vertex is v, image distance. So for concave surface, we also have imaginary circle with center at the middle. And from the center to the vertex of the surface, we have the radius of curvature. And for concave, we have negative r. And for convex, we have positive r. Forgot to mention that. Okay, so this is our object. And from the object to the vertex is our object distance u. And the air is n1, the glass is n2. For both cases, where n2 is greater than n1. So for refraction for spherical surface equation, we have n1 over u plus n2 over v, n2 minus n1 over r, radius of curvature. U is object distance, v image distance, and refractive index of glass, n1 is air. So for magnification equation, we have magnification is equal to height image over height object is equal to negative n1v over n2u. And for the sign convention, okay, let's look at this. Everything is the same like mirror just now, but the only thing is different is the radius of curvature and focal length sign. Okay, meanwhile for radius of curvature, it was positive for convex, meanwhile negative for concave surface. Now we are doing some example. One end of a long glass rod is formed into a convex surface of radius 6 cm. An object is positioned in air along the axis of the rod. Find the image position corresponding to object distance. So we list one by one. We have n1 is air 1, and 2 is glass 1.5, And then we have the radius of curvature 6 cm, positive because it was convex surface. And then we have the position of object 20 cm. So find the image position. We want the V. We are using the spherical refraction of a spherical surface equation of R, and then we have everything ready. Just substitute everything in the equation. 1.5 over, we don't know, minus 1 over 6. And then we are do our maths, and then 6, and then you will get V is equal to 45 centimeter. And the value we got is positive 45. So that tells us that the image form is a real image.